The new topic that we're going to start looking at is quadratic functions, and when we graph a quadratic function we get this shape called a parabola. Now we did go over these fairly quickly during functions. This topic looks at them in depth, so we start looking at roots or solutions, concavity, shapes, whether it's concave up, down. We also look at ones where there's y squared, so they'll be facing left or right. And we start talking about, well, what determines whether they go up or down, or how many roots it has, and what does that mean for the solutions of the equation. So some of the basic stuff that we need to know first though. So the general equation for a parabola is y equals ax squared plus bx plus c, and when it has that form, the graphs look like this. Okay, so you've got two options there, and for the first one, a is greater than 0. So what that means is that you end up with a graph that is concave up, because it faces up if x squared is positive. And we remember that because a is positive, and when it's positive we get a happy face parabola. Okay, I know it sounds silly, but it's a really easy way of remembering what's going on. In the second situation, a is negative, so a is less than 0, and this is concave down. Okay, so it faces down, and we remember that because when it's negative it has a sad face. So some of the things that we need to know about the parabolas. They are symmetrical, so each of these graphs has an axis of symmetry, and that axis of symmetry is going to be straight down the center of the two graphs, which mean that the x-intercepts, so these ones over either side, are both symmetrical about that axis of symmetry. So your intercepts will help you find your axis of symmetry because it's halfway between them. When we have a concave up parabola, then what we have here is this minimum value because our graph never drops below that point. So a concave up parabola has a minimum, but a concave down will have a maximum, and that was really badly drawn. Our concave down parabola is going to have a maximum because it never goes above a certain value. So one of the things that we look at is we have a look at the equation and then we try and find the axis of symmetry. So I'll give you an example. We want to know, well, what happens if you've got y is equal to x squared minus 6x? Well, first we need to graph it. So in order to do that, we're going to consider the intercepts, because once we know the intercepts, we get a very good idea of where this graph is. So for the x-intercepts, we say, well, what happens when y is equal to 0? All right, so 0 equals x squared minus 6x. Now this is why we did all those solving of quadratics. All right, we need to factorize. So 0 is equal to x outside of x minus 6. So y is equal to 0 when x is equal to 0 or 6. So our x-intercepts are 0 and 6. What's our y-intercept? Well, our y-intercept happens when x is equal to 0, which means y is equal to 0. So in this case, the y-intercept is also the x-intercept. Okay, so you can see your intercepts there at 0 and 6 along the x-axis, and the y-intercept is also 0. So looking for our axis of symmetry, you can tell that because our parabola is symmetrical, our axis of symmetry is actually going to happen here at x is equal to 3, because that's halfway between 0 and 3. Okay, and our minimum value we can read off as -9. Okay, so we know the intercepts, we found our axis of symmetry, and we've found our minimum value. Now, it's actually possible to find all of these things out without graphing our parabola, which is really important because factorizing x squared minus 6x is easy, but it's not always that simple. So knowing how to do it in another way is really important. There's a formula for the axis of symmetry, and it is minus b all over 2a. Okay, so if you have something that you can't factorize easily, I mean, if you can factorize it and graph it, then the axis of symmetry is in the middle, and that's no worries. But if you can't, this is how we find the axis of symmetry. So if you're looking at this equation, x squared plus 3x minus 2, knowing that the a will be 1 B will be 3, C will be -2. All you need to do is substitute it into x equals minus b all over 2a. Okay, so minus b is -3, 2a is just 2. So the axis of symmetry for this graph is at -3 over 2, which is also 1.5. Now, this is a happy face parabola because a is positive, it's 1. So if it's a happy face or a concave up, that means it will have a minimum value. Where will the minimum value be? Well, the minimum value is at the axis of symmetry. So the minimum value happens when x is equal to -3. So to work out the minimum value, what we do is we substitute in -3 over 2. So y is equal to -3 over 2 all squared plus 3 outside of -3 over 2 minus 2. So when we do all that substitution, you end up with your answer -17 all over 4. So that is your minimum value. So we know that the axis of symmetry is at -3 over 2. We know the minimum value is -17 over 4. This is why knowing that formula helps, because trying to figure that out on a graph, you're going to be guesstimating, not reading it off accurately. So knowing how to find that really matters. Now that point is really important. That point where the parabola turns, where it's reached its minimum, are both very important things. They have a name and it's called the vertex. So the vertex for this parabola is the point -3 over 2, -17 over 4. Okay, so let's have a look at another example. We want to know the axis of symmetry and the maximum or minimum value. So they're not telling you which one it is, they want you to tell them. Okay, so the first thing you need to do is have a look at your graph and say, well, look at your equation, sorry, and say, well, is this a happy face or a sad face? Is it concave up or concave down? Well, x squared is negative. This is a concave down function. Okay, so we have a sad face. So finding our axis of symmetry, it's still -b all over 2a. But in this case, now be careful, it's not a, b, c straight across. A is the coefficient of x squared. B is the coefficient of x. So we end up with minus. Now b is -4 all over 2 times a, which is -1. So you've got a lot of negatives, and it's really important that you take care when you're looking at those and get them right. You should end up with -2. Okay, so your axis of symmetry is at -2. Now because this is concave down, we are going to get a maximum value. Alright, so our maximum value is going to happen when x equals -2. So substitute that into your equation. Y equals 21 minus -2 all squared minus 4 times -2. And make sure you write this stuff out, guys. Don't try and go straight to the answer or skip the steps. Show the markers that you know what you're doing. Alright, so all of that can go straight into your calculator and you end up with a value of 63. This is why being able to do it without graphing it is going to be very important, because who wants to draw a graph that goes all the way up to 63? Alright, so looking at exercise 9.1, I want you to do as much as you need up to question 14. So have a look. If you're breezing through it, feel free to skip a few, but I want everybody to do all of 15 to 22. Good luck, and I'll see you in class.